Hey, how's it going? Today I'm answering a question which absolutely nobody asked, which is, could you hypothetically fling yourself into a nebula and doggy paddle your way across the cosmos like a majestic space salmon? You may have noticed I don't discriminate between good video ideas and terribly thought out ones. And look, you could have this question occur to you and subsequently spend half an hour digging through Wikipedia articles about nebulas trying to figure out for yourself if taking a cheeky dip in the Orion Nebula is a viable next step for Blue Origin if they followed up their Hydrolox dong rocket with some kind of breast-themed interstellar vehicle. But then again, why not let me do the legwork for you? Let's do it. Alright, so let's get serious, right? This is a serious topic. We need a serious answer. We don't want a repeat of that time my dad did the backstroke in Loch Ness and everyone came to the wrong conclusion. So nebulae are basically giant clouds of gas and dust in space. As with most space things, size is a little hard to grasp, and for nebulas, the size is even more ridiculous than a lot of other quirky space bullshit. To choose one example, back in 1054 AD, people all over the world, Chinese, Japanese, Arab, even Mayan astronomers, all recorded seeing a bright light in the night sky. We know that the light suddenly appeared that July, and it hung around for several years. Thankfully, humans are pretty big into writing things down, so they were kind enough to record where they saw it in the sky, and if you point a telescope in that part of the sky now, you see this thing, the Crab Nebula. Despite only being about 1,000 years old, which for space objects is basically a thing that just fell out of the womb, the Crab Nebula is now 11 light years across. Thing's gigantic. For reference, our solar system alone is ridiculously huge, to the point where it's borderline impossible to mentally conceptualize it properly, and if you took the diameter of Neptune's orbit, which contains every other planet in the solar system, that's only about 0.001 light years across. So on a 1080p image of the Crab Nebula, our entire solar system, Earth, the Moon, the Sun, the asteroid belt, the rocky planets, the gas giants, the abyssal voids between those worlds, would be a tiny fraction of a pixel wide if it were on that image. There's shit going on in this picture that would be like an all-consuming, eon-defining calamitous event if it were happening even remotely nearby the Earth. And yet, things on that scale are so far away that they're hidden within the detail of a single pixel inside some tiny wisp of a tiny lobe in one part of one cloud of one nebula. You know, to fully explore every twist and turn of an amazing, huge alien landscape like this would probably take more than the lifetime of every human being that's ever existed. And that doesn't even factor in the fact that it's, a cloud, so it's moving constantly. Even then, though, it doesn't stop us from learning stuff about it. Like this one, for example, has a teeny weeny little pulsar hanging out in the middle of it, which is pretty cool. Anyway, my point is that nebulas, or nebulae, nebula? Okay, you know what? Fuck you, I'm gonna call them nebulae. Nebulae are absurdly empty because they're so big. The matter is so spread out. All the matter in it, which could be a star or a solar system if it were closer together, is just spread out to a ridiculous degree. The average nebula has fewer atoms per cubic centimeter than you have bitches. Like if you took a cubic centimeter of air from your room right now, you'd find about 10 sextillion molecules in it. Whereas if you did the same in a nebula, it would be a small enough number that you could literally count the individual molecules. Like if you went inside a nebula with an open box and then you closed the box and took it back home and then you looked inside of it, I don't know, say it's a transparent box, I know exactly what you'd say. You'd say, wow, check out this box with absolutely fucking nothing in it. So if you clicked on this video thinking, wow, you can swim through nebulas? No, well, good luck with that. On the bright side, you can't drown in it either. But no, as a person, swimming requires, fluid density to push back against, and a nebula would offer about as much resistance as a wax condom. So you won't be doing the breaststroke through the Horsehead Nebula anytime soon. I mean, you can't even really swim through the air on the International Space Station with human habitable levels of air pressure, so you definitely can't do it in a near vacuum. However... Sorry to interrupt, this is just a quick message to say, statistically speaking, you're probably not subscribed, so I'll make you a deal. Press the subscribe button and I won't come over to your house and do this. Alright, thanks, back to the video. Okay, so there may be a way you can kind of Michael Phelps your way across the universe, although it does require you to cosplay as a kitchen funnel making love to a tube of toothpaste. Or at least, I think that's what this looks like. What do you think it looks like? Man, I should really call her. Oh my god, Zan, you're such a child. Why don't you act your age for once? I don't know how, I've never been this old before! Okay, what the hell is this thing? This is the Bussard ramjet. Or, well, I just watched the Isaac Arthur video on this and he pronounced it Busard. Bussard? I'm just gonna call it the Bussy Ram. The Bussy Ram works by... Okay, no, I'm not gonna call it that. The Busard ramjet works by directing ionized hydrogen and other matter from interstellar space into a gigantic engine intake using electromagnetic forces. Some of that hydrogen undergoes nuclear fusion and releases ridiculous amounts of energy. The byproducts of the fusion reaction, as well as any unused hydrogen or any other matter that just makes its way through, becomes the propellant that gets blown out the back of the spacecraft to produce an equal and opposite reaction. Now, there is a kind of a trade-off with this, which is that when you're moving moving at the kind of unbelievably high speed that you need to be moving at to get this to work in the first place, the interstellar medium that you're flying into almost acts a bit like an atmosphere in that it produces drag, right? You're flying into atoms, those atoms will transfer their momentum to you. So you've got to offset any drag that you experience by producing enough thrust to overcome the drag. And based on my understanding of the calculations done by other people who are smarter and more invested in this than me, who subsequently explained it to other people, who subsequently explained it to me in the kind of plain language and crayon drawings that my brain is capable of understanding, it's apparently not looking too hopeful. This idea is kind of like using a desk fan to push a car. You know, kind of makes sense when you're just making a pencil drawing of it. Makes a bit less sense when you're seriously working out all the forces involved. It also doesn't help that you need to be moving astronomically quickly for it to even have the slightest hope of working in the first place. It's kind of like a 100cc internal combustion engine that only works when your car is already going 400 miles per hour. Sorry, I know I'm not filling you with confidence on this one, but provided I've understood this right, it sounds like the idea is maybe sort of viable in principle if the cross-section of the ship's ion collector is fucking massive. Something else that doesn't really help, at least in terms of us using it for interstellar travel, is that, well, the idea is that you just use it to go wherever you want to go in interstellar space, but it does depend how thick the interstellar medium happens to be between you and where you want to go, and also what it's made out of, because that determines the amount of fuel that you can collect. And it just so happens that our solar system is kind of in the middle of a big open area with nothing in it. Like, interstellar space is particularly empty around our solar system. So yeah, all things said, it's probably not that practical, but if you were to use these in a nebula rather than just anywhere in space, there's potentially a whole lot more ionized hydrogen to suck up and fart out. Then again, that'll also produce more drag, so I don't know. It's funny, it kind of intuitively feels like if you have a civilization that has a lot of these spacecraft and they're all flying through nebulas all the time, it kind of intuitively feels like you'll end up using up that nebula if you do that enough. But when you think about how big a nebula actually is, even if you had colossal Bucid ramjet vehicles with ion collectors the same size as the diameter of the Earth's orbit around the sun, so like big megastructure type stuff, I'm pretty sure the cross-section of gas that this would core out of a nebula as it flies through it would be the equivalent of like a single string of dental floss running through a cube of jello as wide as a major metropolitan area. So even at that scale, I don't think you really need to worry. Anyway, on the whole, yeah, this probably isn't a practical idea, but it's technically a kind of swimming through space, sort of, kind of, not really. Do you reckon if you go fast enough you could have aerodynamic control surfaces to actually maneuver through a nebula? Probably not. That'd be cool though. But this is at least a way to power yourself using the nebula, which is kind of like swimming through it. Although given the necessary scale of the vehicle and the lightweight materials needed for it and the reliance on very specific local conditions to fly through and how much more appropriate other methods of travel are very likely to be, and the fact that you have to be traveling at Mach before this thing is useful in the first place, at least with my current half-baked ass understanding of this, I'd probably bet against this really being a seriously feasible mode of transportation at any point. It is cool as fuck though. I might do a deep dive on this at some point and actually make a full episode on these because they are really cool. But for now, can you swim through a nebula? Not really. Alright, thanks as always to my elite level supporters. Thunderbolt22810, who came from the Crab Nebula, which explains his crustacean-like qualities. Nomad Greg, who doesn't just travel the galaxy, he turbo-explores it. Andrew Maul, who can communicate at the speed of light by just standing there and letting people look at him doing hand gestures. John Bejarano, who can knead dough so hard it fuses tritium. JDK, who can collapse a quantum waveform by raising his eyebrows. Mutantious Doom, who can sprint at warp 6. Stormester Ritter, who's just f***ing covered in beans right now. Nikita Lurie, who bench pressed a neutron star and asked God for something heavier. Aaron Rowe, who negotiated a tenuous peace between matter and antimatter so he could introduce both of them to his parents at the same time. And thanks to all my other supporters too. Don't forget to join the Patreon or the channel membership if you want to be featured in my video credits or chat on Discord. And as always, I'll catch you in the next one. Over now.